and welcome to Math Time Troubles, the show where we journey to the heart of mathematics. Hi, I'm Ange.
And I'm Bea. Today, we are warping into the world of circular functions. Our mission is to use the reference angles to find the exact values and to illustrate the functions themselves.
Let's go.
Let's go.
By the sacred Tita Cruz, what portal is this that brings the veil between dimensions? Who are you?
Greetings, great Pythagoras. We are the humble students from the future, seeking knowledge and wisdom from the past. We wish to understand more about the circular function and the unit circle. Can you tell us more about it?
Oh, the unit circle? The most perfect of all forms? Where my theorem runs supreme? Very well!
Circular functions are commonly known as trigonometric functions because the origin measures of the angles are calculated by the length and coordinates of the terminal point of the arc on the unit circle. Circular functions are functions whose domain and range correspond to the measures of angles with respect to the trigonometric functions. The basic circular functions are sine, cosine, and tangent.
Come join me, my most elegant creations. The world must know your glory.
This is sin, this is cos, and this is tan.
Incredible! Welcome, everyone. Pythagoras, your theorem a squared plus b squared equals c squared is the foundation. How does it become the unit circle?
Observe.
This circle has a radius of 1. Therefore, the hypotenuse of every right triangle we draw within it is 1. This simplifies my theorem into the most beautiful equation, x squared plus y squared equals 1. This is the law of the land. Any point x, y on this circle must obey this rule.
Exactly, and I'm sine.
Since the radius r is 1, my complex ratio opposite over hypotenuse simplifies to just the y coordinate. Sine theta equals y. I am the very measure of verticality.
And I'm cosine. Similarly, my definition, adjacent over hypotenuse, becomes simply the x-coordinate. Cosine of theta equals x. I am the essence of the horizontal. Where sine is the flight, I am the foundation.
And I'm tangent. My definition is opposite over hypotenuse, where tangent theta is equal to y over x, and tangent should not be equal to 0.
That makes it so intuitive. So if a terminal point is at point at negative square root of 2 over 2 and square root 2 over 2, we can just read you off?
Precisely, for that point which is at p negative square root of 2 over 2 and square root of 2 over 2, I am the y coordinate. To solve this, we must follow the formula sine equals y divided by r equals square root of 2 over 2 divided by 1 equals sine equals square root of 2 over 2.
And I'm the x-coordinate. Cosine theta equals x over r, which is negative square root of 2 over 2 divided by 1, and that equals negative square root of 2 over 2. You see the negative sign? That's because we're in the second quadrant, and I, cosine, am negative there.
And for tangent theta equals y over x, which is square root of 2 over 2 divided by negative square root of 2 over 2. This simplifies to square root of 2 over 2 times negative 2 over square root of 2, which equals negative 1.
Which brings us to the bigger question.
What if the function of the angle theta generated by an arc whose length is 5 pi over 6? What is its sin, cos, and tan value?
Amazing question.
Since the length of the arc generated is pi over 6 units, then the measure of the angle is equals to pi over 6, or equivalent to 150 degrees. Hence, the angle is in the second quadrant, so the coordinates of the terminal point would be negative square root over 2 and 1/2. Thus, the three circular functions are
For sine,
y equals 1/2,
for cos, x equals negative square root of 3 over 2.
For tangent,
y over x equals 1/2 over negative square root of 3 over 2 equals 1/2 multiplied by negative 2 over square root of 3 equals negative 1 over square root of 3 times square root of 3 over square root of 3 equals negative square root of 3 over 3.
Wow, nice! But what if we dig deeper? Suppose s is a real number such that sine s is equals to negative 3 over 7 or the y value, and sec s is less than 0 or the x value. What is the value of tan s?
Let P of S is equal to X and Y be the point on the unit circle and on the terminal side of angle S. Since P of S is on the unit circle, we know that X squared plus Y squared is equal to 1, and sine S is equal to Y is equal to negative 3 over 7. We get X squared is equal to 1 minus the quantity of negative 3 over 7 squared is equal to 1 minus 9 over 49, which is equal to 40 over 49, or simplified as x is equal to plus minus 2 square root of 10 over 7. Since secant s is less than 0, we will consider x is equal to negative 2 square root of 10 over 7, then tangent s is equal to y over x, which is equal to negative 3 over 7 minus 2 square root of 10 over 7 is equal to negative 3 over 7 times negative 7 over 2 square root of 10 is equal to 3 over 2 square root of 10 times square root of 10 over 10 is equal to 3 square root of 10 over 20.
Wow! Amazing! But wait!
How do we find the exact value of any angle, especially the big ones like cos 210 degrees or 3 pi over 4 radians?
The magic happens, but you cannot find the value without using the two great secrets, the reference angle and the ASTC law.
The reference angle is the acute angle between the terminal side and the x-axis. Nonetheless, the reference angle is always made positive, whichever quadrant in what direction, counterclockwise and clockwise, is the given angle. Finding the reference angle in each quadrant we have, note, for negative angle, neglect the negative sign. It is the key that unlocks the common values you have memorized. Things to remember. If the angle is in quadrant 1, then the reference angle will be the same as the value of the angle theta. If the angle is in quadrant 2, then you need to subtract 180 minus angle theta. If the angle is in quadrant 3, then you need to subtract angle theta minus 180. If the angle is in quadrant 4, then you need to subtract 360 minus angle theta.
For example, we need to find the reference angle of the given angle in standard position, 24 degrees. Since the given angle is in the third quadrant, then we have theta minus 180 degrees, which is equal to 24 degrees minus 180 degrees, which is equal to 24 degrees. Then 24 degrees is the reference angle.
Here are the values of the basic circular functions for certain acute angles. For sin theta, 0 degrees is equal to 0, 30 degrees is equal to 1 half, 45 degrees is equal to square root of 2 over 2, 60 degrees is equal to square root of 3 over 2, and 90 degrees is equal to 1. For cos theta, 0 degrees is equal to 1, 30 degrees is equal to square root of 3 over 2, 45 degrees is equal to square root of 2 over 2, 60 degrees is equal to 1 half, and 90 degrees is equal to 0. For tan theta, 0 degrees is equal to 0, 30 degrees is equal to square root of 3 over 2, 45 degrees is equal to 1, 60 degrees is equal to square root of 3, and 90 degrees is undefined.
We also need to remember the rules of the sign of the circular function, or simply the ASTC.
Legend. Q stands for quadrant. A means all circular functions are positive. S means only sine and cosecant are positive. T means only tangent and cotangent are positive. And C means only cosine and secant are positive. Let this be your guide when you are asked to determine the sign of the function in a quadrant. It is easy to memorize using ASTC.
Nice! I get it now.
But back to Anjali's question, how do we find the values of the three circular functions of theta whose terminal side is at 3 pi over 4?
To answer your question, we need to convert 3 pi over 4 to degree. So 3 pi over 4 multiplied by 180 degrees over pi equals 135 degrees. And this lies in the second quadrant. Then the reference angle will be 180 minus theta equals 180 degrees minus 135 degrees equals 45 degrees. Using the chart, we have sine 3 pi over 4 equals sine 135 degrees equals sine 45 degrees equals square root of 2 over 2.
For cosine, we have
Cosine 3 pi over 4 equals cosine 135 degrees equals negative cosine 45 degrees equals negative square root of 2 over 2.
And for tan, we have tangent 3 pi over 4, which is equal to tangent 135 degrees. Tangent 135 degrees is equal to negative tangent 45 degrees. Negative tangent 45 degrees is equal to negative 1.
Wow! Amazing! Another question.
To find the exact values of the three circular function, given the function tan is 210 degrees.
Since the angle is in quadrant 3, the reference angle is theta minus 180 degrees is equal to 210 degrees minus 180 degrees. 210 degrees minus 180 degrees is equal to 30 degrees. Then, tangent 210 degrees is equal to tangent 30 degrees. Tangent 30 degrees is equal to square root of 3 over 3.
For sine, 210 degrees equals negative sine 30 degrees equals negative 1 half equals negative 1 half.
Cosine of 210 degrees equals negative cosine of 30 degrees, which equals negative square root of 3 over 2.
Wow! Amazing!
For the last question, how do we find the values of the other 5 circular functions if sine theta is equals to 12 over 13 and lies in the second quadrant?
From the equation of the unit circle x squared plus y squared equals 1, we can obtain the equation sine 2 theta plus cos 2 theta equals 1. Substitute sine theta equals 12 over 13, we can solve for cos theta. Then we have cos 2 theta equals 1 minus sine 2 theta, then cos 2 theta equals 1 minus 12 over 13 squared equals 1 minus 144 over 169. We can have the answer 25 over 169. We can simplify this answer to cos theta equals square root of 25 over 169 or positive negative 5 over 13. Since cos theta is negative in the second quadrant, then cos theta is equals to negative 5 over 13.
Show us. Let us use this example.
How do we find the exact value of cos 585 degrees?
A fine choice.
First, we find the reference angle. We need to find coterminal angle between 0 degrees and 360 degrees. We do this by subtracting 360 until we are in range 585 minus 360 equals 225. So 585 degrees is coterminal with 225 degrees.
225 degrees is in the third quadrant. Now,
The reference angle is the angle to the nearest x-axis. 225 degrees minus 180 degrees equals 45 degrees. We know that the cosine of 45 degrees equals square root of 2 over 2.
now we apply the ASTC rule from the module.
All functions are positive in quadrant 1. Sine is positive in quadrant 2. Tangent is positive in quadrant 3. And cosine is positive in quadrant 4. We are in quadrant 3, where only tangent is positive. Therefore, I, cosine, am negative in the third quadrant.
Oh, so you take the value from the reference angle and apply it to the quadrant? Precisely.
So, cosine of 585 degrees equals cosine of 225 degrees, which equals negative cosine of 45 degrees. And that is negative square root of 2 over 2.
Wow! Amazing!
Amazing! We understood a lot. You have not only shown us how to illustrate the circular functions, but also shown us how to use the reference angles to find the exact values anywhere on the circle.
Amazing guests, thank you so much. We truly learned a lot about this journey.
Remember, all is number and all is ratio. Understand the circle and you will understand the universe.
Bye-bye!
I think it's already time. We need to go back to our own world.
We truly learned a lot today. We learned that the unit circle isn't just a diagram, but it's a map.
And that reference angle and the ASTC law are the compass that helps us navigate the map to find exact values anywhere.
So next time, if you're lost in a tough trig problem, just remember
To come full circle.
Thanks for traveling with us.
Stay curious.